टाइम भेटतो तर मग करते जॉईन.
पण असे बरेच जण आहेत ना, म्हणजे करत नाहीयेत असे.
समजत नाही ना,
पण
मग काय असाइनमेंट्स वगैरे दिले तर.
हा हा हा. चालेल. तर assignment number 2 is there, and that assignment number 2 contains the first question: explain the free space propagation model for the mobile communication. And that free space propagation model is related to the Friis formula, basically. And with the help of that particular Friis formula only, we are going to solve the problem. As we know that PR divided by PP is equal to AET into AER divided by R square into lambda square. Also, we can write that GT and GR in terms of lambda, and we can extend that particular equation. And in that equation, we have to add one more thing, that is the loss in the medium. That one thing we have to add. Second problem is there, and that particular problem basically we can solve with the help of Friis formula only. Explain the three basic propagations. आपण जी propagation शिकलेलो आहे, तर तीच propagation, reflection, refraction, and diffraction, these three different propagations are there, and we are going to see, means whatever the modules used for analysis of these propagation and all these things we have discussed. Explain the Fresnel zone geometry. That particular part is related to the second half um, of this chapter, and it is related to the small scale fading. Explain the ground propagation, that is also there, and explain the indoor propagation, outdoor propagation models. These are the different models we have discussed, and accordingly you have to put up in that. Explain the factor influencing the small scale fading. कुठले कुठले फॅक्टर इन्फ्लुअन्स होत आहेत स्मॉल स्केल फंडिंग मध्ये, दॅट वी हॅव टू cover here. As we all know that the multipath propagation is there, and different signals are received at the uh, receiver as well as at the base station also. So different things we have discussed about. These are the um, influencing factors in case of the small scale guiding. Write a note on the Doppler sheet. Explain the parameters of the mobile multipath channel in details and discuss the types of the small scale guiding. So these are, and measurement is one of the thing. I think one thing I have to add, and adding that I am going to upload this particular assignment. What you do on that is first assignment. I think you have solved and you have uploaded on the Moodle, I think. So a due date of the first assignment is completed, or we can say it's gone, and you have to submit it as early as possible. Okay.
ओके सर.
So these are the things we are going to means once the assignment questions are there, we will discuss about the assignment questions with the help of whatever um, we have discussed in this particular part. So line of sight and non-line of sight communication is there, and propagation models. What are the different propagation models, indoor and outdoor? That particular we have discussed. Small scale or the shading models are there. This space propagation model is given here, and that particular is suppose means it is supported by only the Friis formula, and we have discussed about the Friis formula very well, and GT and GR are the gain of the transmitter antenna, gain of the receiver antenna. G is equal to 4 pi AE divided by lambda square. So that particular part is we have discussed. AIRP is the effective isotropic radiated power and defined as the PT into GT. Um, we have not doesn't have any requirement of the AIRP, that is the effective isotropic power radiated by the antenna. Uh, these are the things what we can say the related to the path loss, how we can calculate the path loss from linear to the logarithmic, that is the dB scale, or in dBm only. So PL is equal to minus 10 dB log. That is the conversion we did, and that conversion is very important in case of the whatever the path losses are there. These particular are in higher, we can say the uh, number of decimal points are there, and in that case, if we are going to write it as 90 dB, that's something like that. Nine zeros are there before one, and decimal point is there. So it's a writing is also very simple. Also, the means these are the things you have to keep in mind, and you have to work about this particular. हे एक एक्झाम्पल दिलेलं होतं कॅल्क्युलेशनसाठी आणि हे दुसरं एक्झाम्पल आहे तेच तिथे आहे मला वाटतं. तर ते एक्झाम्पल तुम्ही सॉल्व्ह करायचं आहे आणि ते अपलोड करायचं आहे. रिफ्लेक्शन, रिफ्रॅक्शन, स्कॅटरिंग, these are the three propagation mechanisms, and one question is there about the propagation mechanisms, explanation of the propagation mechanisms. So that particular question you can attempt with the help of this whatever the information given. Also, you can refer the rapport chapter number 2, and in that chapter actually they have given very well. If and unless if you are getting that the limited information is there in the PPT, then you can refer the book also. So reflection dielectric in this case, I think derivation is there, and that particular derivation you have to solve. That is the ground reflection ray module, and this particular is the reflection ground reflection two ray module is there, and it's a derivation. So you have to solve the derivation and complete that particular question. Phase difference, diffraction. My phase diffraction modules. You can add up in this particular my phase diffraction modules and all. Here is one example, but I am not put that particular example. So one more thing, one of these questions I am going to add up, and I am going to display this particular assignment. So maybe if this problem is there, then you have to attempt this problem. So two types of the problems will be there, and remaining are the theory questions. This is the type of the assignment. A fractional zone is one of the questions. That is fractional zone, how we can represent, and what are the different aspects of the fractional zone. This is related to the second half of the chapter, that is the small scale padding and the multipath population. Three different important effects we have discussed about, and whenever they are going to ask related to the small scale padding, so these are the basic things you have to write. So factor influence in the small scale padding and the three most important effects related to the small scale padding. Doppler shift is one of the thing which affects in case of the mobile communication, and as we know that Doppler shift is better in case of the radar, but it is not better in case of the, we can say, the mobile communication, because Doppler shift happens whenever the signal is goes and incident on any another object, and then the Doppler shift is taken place. So that there is apparent change in frequency of the reflected waveform, and it may create the noise, and that is the basic thing we have to keep in mind. And equations of these are also there, and you have to go through these particular equations. I think better to write the problem related to this particular small scale value with Doppler radar. I will put this particular problem in the assignment, and you have to solve this particular assignment problem. Okay. So here they have shown that whatever we think that very simple equation is there, and in that equation we have to add up the whatever the quantities given and solve this. Impulse response module, related to the impulse response module, much more things are not added in the assignment. These are the some systems, that is the direct RF pulse system, small scale multipath measurements. This problem is also this question is also not there. So I will put this question also there in the assignment. Advantage and disadvantage of algorithms are given. Flat padding, frequency selective padding, fast padding, slow padding. So these are the things. So I think a relatively small scale padding. Some things I wanted to add. I will add this particular and I will put this assignment of the second chapter. Okay. Assignments are very important as far as your question paper is concerned. That's why the assignment you have to solve and upload. Okay. Everyone has to do. Just a minute. Just a minute. Before going to the next chapter, one of the things I wanted to discuss with you, and it is the extra, I think, and it's very important to know us. Okay, so, and that's why. And Akansha, your favorite chapter is there, and that particular is the networking, which is the next chapter. Okay, we'll discuss of the networking in the next lecture. Okay, so this particular thing is very important as far as the our mobile wireless communication is concerned. This is the document given by the Silicon Labs, and it gives the key priorities of the sub-gigahertz wireless deployment. Now, what it is? Basically, sub-gigahertz means what? गिगाहर्टच्या अगोदरच्या ज्या फ्रिक्वेन्सीज आहेत त्यांना म्हणतात सब गिगाहर्ट्ज. ओके सो सो what it is, that is 1 GHz आहे. 1 GHz खालच्या फ्रिक्वेन्सी म्हणजे 300 MHz to 900 MHz फ्रिक्वेन्सी येतात त्यांना म्हणतात सब गिगाहर्ट्ज. नाउ rather than using the 2.4 gigahertz, which is for the Bluetooth used or the mini applications where the this particular frequency is used, what is the advantage of using the 300 megahertz to 900 megahertz that we are going to see? And this is given by the Silicon Labs, and Silicon Labs is the one of the leading company in manufacturer of the sub gigahertz wireless equipments. Okay, and that's why they have published this particular document, and it is in Austin. To build an advanced wireless system, most developers will end up the choosing between two industrial, scientific, and the medical. That is, ISM band is there. ISM band. What is ISM band? Industrial, scientific, and medical radio band. Optional 2.4 gigahertz or sub gigahertz frequencies. Okay, so pairing one or other with the system's highest priority will provide the best combination of wireless performance and the economy. आता प्रायोरिटीज काय असू शकतात म्हणजे एखादे चॅनल डिप्लॉय करायचं आहे तर त्याच्या प्रायोरिटीज व्हॉट आर द डिफरंट प्रायोरिटीज. सो प्रायोरिटीज आर लाईक दिस. व्हॉट इज द रेंज ऑफर्ड बाय दॅट पर्टिक्युलर चॅनल म्हणजे तुम्ही यूज करणाऱ्या ज्या फ्रिक्वेन्सीज आहेत तो चॅनल आहे इथे. Okay, second one is the power consumption. Third one is the data rates. How much is the data rate offered by that particular channel? That particular thing we must know. Fourth one is the antenna size, and it is one of the most important parameter which we have to consider, because if the antenna size is more in that particular case, what happens? How to install the antenna on the gadget, that is the main problem will be there. Okay, and that's why the antenna size is one of the most important parameter. We'll discuss about this particular at the time when it comes. So interoperability, that is we must know that how Bluetooth is connected to the mobile and another gadgets are connected with the help of the Bluetooth. That is the interoperability and the worldwide deployment. Means if at all the channel is there, but it is possible to deploy all over the world, because these frequencies are not going to interfere any another frequencies which are used in previously. Okay, so these are the different parameters which parameters, so whatever the written here, that is range, power consumption, data rate, antenna size, interoperability, and the deployment. That's worldwide deployment. These are the parameters. We'll discuss one by one and how the sub-gigahertz frequencies are important in order to use these sub-gigahertz frequencies for the deployment of these particular things, and over these things, how it is effective. So, Wi-Fi, Bluetooth, Zigbee technologies are heavily marketed, and it is using the 2.4 gigahertz protocol used extensively in today's market. However, for the low data rate applications such as the home security, automation, smart metering, sub-gigahertz wireless systems offer several advantages over 2.4 gigahertz. Okay, including the larger range, reduced power consumption, low deployment cost, and the operating costs. Okay, so these particular are the advantages over the 2.4 gigahertz means sub-gigahertz over the 2.4 gigahertz. In case of the sub-gigahertz radios means sub-gigahertz frequencies. Sub-gigahertz radios can offer relatively simple wireless solution that can operate uninterrupted on the battery power alone for up to 20 years. एक बॅटरी टाकली तर 20 वर्ष चालू शकते असा याचा अर्थ आहे. नोटेबल ऍडव्हान्टेजेस ओव्हर द 2.4 gigahertz radio. One thing I have to uh, explain you related to the frequency. As frequency goes on decreases, means if the frequency is 2.4 gigahertz you are using, and if the frequency is around 600 megahertz you are using. So in that particular, what is the difference is taking place? The frequencies are higher. As the frequencies are higher, so power requirement is more in case of the higher frequency. That is the basic things we have to keep in mind in case of the mobile communication. So whenever we are using the higher frequencies, at that time you have to use the more power. That is the main thing. Why this particular thing happens? Do you know about it? म्हणजे जर हायर फ्रिक्वेन्सी यूज केलं तर पॉवर जास्त कंझ्युम होती. हे का होतं असं डू यू नो अबाउट इट? माहित आहे का तुम्हाला याच्याबद्दल काय? हॅलो वैष्णवी, आर यू विथ मी? वैष्णवी?
Yes, sir.
Okay. Do you know the why? What is the reason behind higher frequencies? If you are going to higher frequencies, then power requirement is also higher. Why it is so? Don't know. Okay, I will. Normally, whatever the circuits, in case of the digital, whatever the circuits are there, these are the switching circuits. Switching circuits means internally they are having the switching transistors. Is it or not? So, number of switching transistors are there in the digital technology, and what happens? These transistors are working in either cutoff or saturation. These are the two things. Okay. When they are moving from the saturation to cutoff or cutoff to saturation, they are go through the active mode. That is the one thing. And when there is a switching, म्हणजे ह्या केसमध्ये ज्यावेळी आपण एखादी फ्रिक्वेन्सी यूज करतो किंवा स्विचिंग टेक्नॉलॉजी यूज करतो, त्या केसमध्ये पॉवर कन्झम्पशन कुठं होणार आहे? तर ज्यावेळी स्विचिंग होणार आहे, म्हणजे सॅच्युरेशन टू कट ऑफ स्विचिंग होणार आहे किंवा स्विचिंग फ्रॉम द कट ऑफ टू सॅच्युरेशन, त्यावेळेस पॉवर रिक्वायरमेंट आहे. बरोबर आहे का नाही? तर हायर फ्रिक्वेन्सी असेल तर स्विचिंग पर युनिट टाइम इज मोर, अँड दॅट्स वाय power consumption more in case of the higher frequencies. Though in case of the lower frequencies, what will happen? That is switching per unit time is less, and that's why power requirement is less. Okay, so that is the very basic thing where the power requirement is more in case of the higher frequencies used and lower in case of the lower frequency used. So that's why when anyone goes for the sub-gigahertz channel, that is around 300 megahertz to 900 megahertz, in that the power requirement is lesser than the whatever the power requirement for the Bluetooth channel, like Bluetooth, Zigbee, Wi-Fi. त्याचे जे चॅनल्स आहेत त्याला जी पॉवर रिक्वायरमेंट आहे ती जास्ती असते. ओके, सो That is the one thing I would. आता ही तर रेंजचा एक प्रॉब्लेम मी सांगितलेला आहे बघ. Narrow band operations sub gigahertz radios enables the transmission of the range of the kilometers or more. This is also one of the advantage of the sub gigahertz channels. काय आहे तर रेंज वाढवून मिळते आपल्याला जर आपण लोअर फ्रिक्वेन्सी यूज केली तर. आता ह्याचं रिझन तिने खाली दिलेलं आहे 3 different reasons are there. So this allows the sub-gigahertz nodes to communicate directly with the distance hub without hopping off the node to node. It is often required using the much shorter range. So a range is there and which is the much shorter in case of the 2.4 gigahertz and much higher in case of the sub gigahertz which is 10 to 900 megahertz. That is the one thing. And ते का आहे ते आपण आता डिस्कस करूया. There are 3 primary reasons for the sub gigahertz superior range performance over 2.4 gigahertz applications. As radios pass through the walls or other obstacles, signal weakens. Higher frequency signal weakens more and lower frequency signals weakens less. That is the one of the reason. Attenuation rates increases at higher frequency. Therefore, 2.4 gigahertz signal weakens faster than the sub-gigahertz signal. हे एक कारण आहे. म्हणजे त्याला पेनिट्रेट व्हायचं आहे वॉल मधून ऑब्स्टॅकल्स मधून. त्यावेळी काय होणार आहे तर जास्तीत जास्त अटेन्युएट कुठला सिग्नल होणार तर हायर फ्रिक्वेन्सीचा 2.4 gigahertz. बट लोअर सिग्नल्स विल नॉट अटेन्युएट as they are attenuated for the 2.4 gigahertz. Okay, ते पण attenuate होतील पण ते कमी attenuate होतील. That is the one thing we have to keep in mind. Second, 2.4 gigahertz radio waves also fade more quickly than the sub-gigahertz waves. They reflect off the dense surfaces. In highly congested environment, 2.4 gigahertz transmission can weaken rapidly with the adverse effect of the signal quality. Fading is there, and fading, as we know, that means multipath reception. In case of the multipath reception, what is that? That is nothing but the fading. आता फॅडिंग झाल्यानंतर जो सिग्नल होतो तो मोर वीक होतो इन केस ऑफ द 2.4 gigahertz, but it is not weakens in case of the sub gigahertz. That is the second one. So fading is the second part. Third one is even though the radio waves travel in straight line, they do bend. They do bend when they hit the solid edge. Okay, so as frequencies decreases, the angle of the diffraction increases. Okay, so allows sub gigahertz signals bend farther around the obstacle and reducing the blocking effect. जेवढं बेंडिंग ऑफ सिग्नल 2.4 gigahertz मध्ये होतं त्याच्यापेक्षा जास्त बेंडिंग सब gigahertz मध्ये होतंय आणि त्याच्यामुळे रिड्यूस द ब्लॉकिंग इफेक्ट. म्हणजे एखादी बिल्डिंग आहे बिल्डिंगच्या पलीकडे आपला रिसिव्हर आहे तर बेंडिंग इज पॉसिबल इन केस ऑफ द सब gigahertz, बट the bending is not much possible with the 2.4 gigahertz, and that is the third reason. So first reason is the attenuation through the walls or any obstacles is there is less in case of the sub gigahertz. Second one is the fading. Because of the fading, quality of the signal is better in case of sub gigahertz, but it's less in case of the 2.4 gigahertz. Also, more thing is radio through. Third one is the bending of the signal. Bending of the signal is more in case of the sub gigahertz and less in case of the 2.4 gigahertz. So these are the things why the sub gigahertz frequencies are normally used for the lower frequencies. Normally used for the communication purpose. आता इथं त्यांनी सांगितलेलं आहे बघा, please equation demonstrates the propagation characteristics of the sub gigahertz radio, showing that the path loss 2.4 gigahertz is 8.5 dB higher than the 9 megahertz. काय सांगितलंय? Propagation characteristics sub gigahertz radio, showing that the path loss is more in case of 2.4 gigahertz. How much it is? 8.5 dB than the 900 megahertz. That is also one of the reasons. This आपण वरती discuss केलं. Path loss is more at the 2.5 higher frequencies. Path loss is less at the lower frequencies. This translates that the 2.67 into longer range of the 900 megahertz. म्हणजे जर समजा सिग्नल अॅटिन्युएट होतोय किंवा पाथ लॉस जास्त आहे म्हटलं तर तो अॅटिन्युएट होणार आहे. म्हणजे काय, आपल्याला जी रेंज मिळणार आहे ती कमी मिळणार आहे. आणि रेंज इन केस ऑफ द 900 मेगाहर्ट्ज इज मोर. Radio since range approximately doubles with the help of the 6 dB increase in power. Okay, so to match the range of the 900 megahertz radio, 2.4 gigahertz solution would need the greater than 8.5 dB additional power. So here is the problem of the power comes in picture. That is, we can increase the range of the communication system. Also, we can have a better on the effective power utilization for that particular system. Okay, so these are the things very important in case of the sub-gigahertz. So advantages behind sub-gigahertz is more than the 2.4 gigahertz. Okay. Then low interference, that is this always crowded is 2.4 gigahertz crowded. म्हणजे Zigbee ला यूज करतो तोच, Bluetooth ला यूज करतो तोच, Wi-Fi ला यूज करतो तोच. Also, some mobile channels are using 2.4 gigahertz. Various sources such as the home, office Wi-Fi hubs, Bluetooth enables computers, cell phones, peripherals, microwave ovens. याचा सगळ्याचा इफेक्ट जो आहे तो त्या 2.4 gigahertz वरती जास्ती येतो. This traffic jam of the 2.4 gigahertz signal creates a lot of interference. Sub-gigahertz ISM band are mostly used proprietary low duty cycle links and not as likely to interfere with each other. Okay, so thicker the spectrum means easier the transmission and fewer the retrace, which is more efficient and saves the battery power. आता हा इंटरफरन्स हा भाग आहे. इंटरफरन्स का जास्त आहे 2.4 gigahertz, तर सगळं ट्रॅफिक तिकडे जाम झालेलं आहे. म्हणजे वायफाय तेच यूज करते, ब्लूटूथ तेच यूज करते, झिगबी तेच यूज करते, मोबाईल तेच यूज करते. And because of that, the more number of signals are there in the environment, and that's why the interference is more at 2.4 gigahertz. And whatever the 900 megahertz channel is used, that particular channel not uses the more this thing. Okay, so and that's why it is beneficial to use the sub gigahertz for the lower interference. आता पॉवर सांगितलं बघा इकडे. Both power efficiency and the system range are as a function of the receiver's sensitivity plus the transmission frequency. काय म्हणते ते, द पॉवर इफिशियन्सी आणि सिस्टीम रेंज हे दोन्ही पण कशाचे फंक्शन आहेत, तर रिसिव्हरची सेन्सिटिव्हिटी अँड द ट्रान्समिशन फ्रिक्वेन्सी. सो सेन्सिटिव्हिटी इज इनव्हर्सली प्रोपोर्शनल टू द चॅनल बँडविड्थ. Sensitivity is inversely proportional to the channel bandwidth. Sensitivity, I think we have to define the sensitivity. That how much is the small signal that can be recognized by the receiver? That is nothing but the sensitivity. Okay, so sensitivity and the transmission frequency, receiver transmission frequency, both are in tune with the power efficiency and the system range, we can say. Okay, so sensitivity is inversely proportional to the channel bandwidth. आता बँडविड्थ जेवढी मोठी असेल तेवढी सेन्सिटिव्हिटी कमी असणार असं म्हणता येते. सो द नॅरोअर बँडविड्थ क्रिएट्स द हायर रिसिव्हर सेन्सिटिव्हिटी, अलाउज द इफिशियंट ऑपरेशन ऍट लोअर ट्रान्समिशन लेट्स. आता काय, आपल्याला बँडविड्थ वाढवायची असते, म्हणजे डेटा रेट वाढवायचा असेल तर बँडविड्थ वाढवायची आहे. डेटा रेट वाढवला तर सेन्सिटिव्हिटी कमी होणार आहे. दॅट इज द थिंग वी हॅव टू कीप इन. आता ह्याच्यानंतरचा जो पॉईंट सांगितला आहे तो फार महत्वाचा आहे, आणि तो काय आहे बघा. फॉर एक्झाम्पल 300 megahertz, if the transmission and reception of the crystal errors that is R of the 10 ppm that is 10 ppm parts per million. 300 megahertz मध्ये because of interference what happens, 10 ppm तेवढा नॉइज आहे आपण असं म्हणू. Error is the 3 kilohertz in case of 300 megahertz. For the application efficiently transmit and receive, minimum channel bandwidth is 2 times the error rate. 2 times the एरर रेट. म्हणजे आपल्याला तो कुठला एक हे आहे बघा, लॉ आहे, सॅम्पलिंग थेरम आहे, त्याच्यानुसार आपल्याला डबल करायला पाहिजे तर 6 kHz पाहिजे, विच इज आयडियल इन केस ऑफ द नॅरो बँड ऍप्लिकेशन. Same scenario at the 2.4 GHz requires minimum channel bandwidth is 48 kHz. 48 kHz is the minimum channel bandwidth required, which wastes the band for the narrower applications and requires sustainability for the more operating power. आता bandwidth वाढली की power requirement वाढते. आणखीन though this particular bandwidth requirement in case of the 900 megahertz is also very, very less. Okay, it is around, I think, 30 kilohertz, around that. And that's why the power efficiency is also better in case of the sub-gigahertz. In general, all radio circuits running at higher frequencies, including the low noise amplifier, power amplifier, mix synthesizer, need more current to achieve the same performance at lower frequencies. आता ही जी सगळी ते amplifiers and हे ते आहेत, as I told you that more the frequencies, more switching will be there, more switching, more power consumption. So this particular part also is here. So range, low interference at low power consumption are basic advantages of the sub-gigahertz applications over 2.4 gigahertz applications. One of the disadvantage of the sighted is that the antennas are the larger than those used for the 2.4 gigahertz. आता बघा, लोअर फ्रिक्वेन्सीला गेले की अँटेना साईज वाढते आणि तो एक डिसएडव्हान्टेज आहे ह्याचा सब gigahertz चॅनलचा. ओके, सो the optimal antenna size for 433 megahertz application, for the instance, can be up to the 7 inches. And however, the antenna size required is inversely proportional to the frequency. If the node size is an important design for consideration, develops can raise the frequency up to 950. So, in order to employ the smaller antenna, we have to go for the 950 megahertz. That is the one thing. But many more miniaturization techniques are available for the antenna. How to decrease the size of antenna? So this number of techniques are there, and with the help of this number of techniques, one can miniaturize, one can less the size of the antenna for that particular frequency. That is, जेवढी 2.4 gigahertzचा जेवढा मोठा antenna लागतो, तेवढाच antenna one can design for the 300 megahertz or anything else also. Okay, so this is the thing we have to keep in mind. Applications trend 2.4 gigahertz versus the sub gigahertz application trend. That is, 2.4 gigahertz and the sub gigahertz technologies are expanding in the consumers. So industrial automotive marketplace. आता ह्या कुठं कुठं डिप्लॉयमेंट होऊ शकते ते आपण बघणार आहे. तर 2008 मध्ये 2.4 gigahertz CAM यूज केलं आणि 172 million units, while the sub gigahertz CAM almost 3 times than that of the number of 492 million. तर इथं दोन डायग्राम दाखवलेले आहेत आणि 2.4 gigahertz मध्ये काय काय यूज होऊ शकतं आणि सब gigahertz मध्ये काय काय होऊ शकतं. तर रेंज बघा मीटर्स मध्ये असते इकडं. GDO is nothing but the garage door opener साठी इट्स बेटर आहे. आफ्टर मार्केट RKE म्हणजे रिमोट कीलेस एंट्री साठी ते चांगलं आहे. ऑटोमोटिव्ह मध्ये TPMS आणि RKE म्हणजे प्रेशर मॉनिटरिंग सिस्टम्स ज्या आहेत त्या that is nothing but the TPS and the RKE, that is the remote keyless entry. त्याच्यासाठी जास्तीत जास्त सब gigahertz यूज होतो. कॉर्डलेस मध्ये 2.4 gigahertz, वायफाय मध्ये, ब्लूटूथ मध्ये, PC पेरिफेरल्स आणि गेम कंट्रोलर्स याच्यामध्ये जास्तीत जास्त करून 2.4 gigahertz यूज होतो. आता इकडे बघा टॉयज आहेत जे हे यूज करतायत. कंझ्युमर मेडिकल, स्पोर्ट्स इक्विपमेंट्स are using the 2.4 gigahertz, and meter home displays are also using the 2.4 gigahertz. RFID, security system and home automation, they are using also the sub-gigahertz channels. So these are the some means as I told you that it's a range in terms of the kilometers, the range of the sub-gigahertz. But in case of the 2.4 gigahertz, it is the 10 meter or the 20 meters only. Only thing is that we have to keep in mind that the where the bandwidth requirement is less, the sub-gigahertz channel, sub-gigahertz frequencies are very much of popular frequencies. Okay. There are several markets such as the toys, medical equipment, security systems, and the building automation where both wireless applications are used in the same system. For example, in building security 2.4, radios are needed to serve the high data rate, video cameras while the proximity, um, pressure and acceleration sensors are networked using the sub-gigahertz. Means deployment of these two different frequencies is depends on the applications also. If the requirement is that the higher data rate we need and it is for the smaller distance, one can go for the 2.4 gigahertz only. But distance sensors are there and we have to get the data from these particular sensors, one can go for the sub-gigahertz channels. Range, power consumption, antenna size, data rates are not only design consideration for the wireless applications. Worldwide deployment and the software stack size cost also have to be addressed. So these are the things we have to keep in mind. And worldwide deployment and the standard priority solutions, sub-gigahertz applications for the smart grid technologies. These are also the things we have to keep in mind. I'm going to share this particular document with you, and you can compare this particular as the wireless technologies is one of the things which is leading all where. So which are the frequencies one can use for the lower bandwidth and the higher frequencies, higher range requirement, and also the lower power requirement. So that is the very good sub-gigahertz. So one can use that particular sub-gigahertz. In sub-gigahertz, you may have used this particular sub-gigahertz, that is 433 megahertz um, uh, uh, in your projects mainly for the transmission and reception purpose. Also, the battery requirement is less, and that's why huge we can say the this thing is there. Requirement is there. Also, 10 or 20 years we can use that one particular battery with the help of this sub-gigahertz because battery requirement is less necessary in the sub-gigahertz. Okay, one of the different we can say the type of the channel and all these things we have discussed today, that is the frequencies above 1 gigahertz and frequencies below 1 gigahertz. What are the applications? What is the range requirement? What is the battery requirement? What is the bandwidth, antenna size, deployment, and cost for this thing. So these are the things we have discussed today. We'll stop here. We'll see in the next lecture.